Let us solve the third problem. If Laplace of f of t is equals to phi of s and g of t is equals to 0 for t between 0 and a, and it is equals to f of t minus a for t greater than a, then you have to prove that Laplace of g of t is equals to e power minus as into phi of s. Okay. Now in this particular problem, Laplace of f of t, they have written phi of s. That means there is a function f of t and its Laplace is some other function in s, which is phi of s. So let us begin. We have to find Laplace of g of t. So I will say that Laplace of g of t is equals to 0 to infinity e raised to minus st into g of t into dt. This is our definition. We are finding here Laplace of g of t. Now, as the value of g of t is 0 for 0 to a, therefore when we split the limit, we begin with a to infinity, as from 0 to a the value will be 0. So, e raised to minus st into the value of g of t is f of t minus a into dt. Now f of t minus a. So what we do here, we use the substitution method. We say we substitute let t minus a is equals to u. So if we differentiate with respect to t, we will get 1 is equals to, because derivative of t is 1, derivative of 1a is 0. So I will get 1 is equals to du upon dt. That is, we can also say that dt is equals to du. And regarding limit, the variable t is varying from a to infinity. Variable t is varying from a to infinity. So therefore, the respective limit for u will be, see, when the value of t is a, what we get, value of u as a minus a 0. So what we say that the variable u will vary from 0 to, now when t is infinity, so u is also going to be infinity. Therefore Laplace of, we can say that Laplace of g of t will be equals to 0 to infinity e raised to minus s t will be equal to u plus a into dt will convert to d. What we get here is 0 to infinity e raised to minus su into e raised to minus as into du is equals to e raised to minus as into 0 to infinity e raised to minus, here f of u is also there, f of u into du. So e raised to minus as into f of u into du. So this will become e raised to minus as, we can take out because we are integrating with respect to u, and in e raised to minus as we have no u term. So I will say that this is e raised to minus as into integration of e raised to minus su into f of u into du. This is e raised to minus as. Now as we have made a substitution that t minus a is equals to u, and we got everything in terms of u, now again we can make a substitution that u is equals to t. So we get e raised to minus s t into f of t into dt. If you are not doing this substitution, then also it is okay, but as we have formula in the variable t, we convert it. Now this is e raised to minus as, and this whole thing is Laplace of f of t. And Laplace of f of t, in the beginning itself we have seen that it is phi of s. So these are few problems of Laplace which we have solved using the definition of Laplace. I will give you some problems for practice. You solve it yourself. I will also give you the solution, but in next class. You solve it yourself. Within half an hour, I think you will be able to solve the problems. So try these problems. So some problems for practice. I have given 6 problems. First problem: f of t is t for t between 0 and half. It is t minus 1 for half and 1, and 0 for t greater than 1. Second problem: f of t is sin 2t for t between 0 and pi. It is equals to 0 for t greater than pi. Third problem: f of t is equal to t when t is between 0 to 3 and 6 when t is greater than 3. Fourth problem: f of t is cos t for t between 0 to 2 pi and is 0 for t greater than 2 pi. Fifth problem: it is t square for t between 0 and 1 and 1 when t is greater than 1. Last problem: f of t is 0 for t between 0 to pi and sin square t minus pi for t greater than pi. So solve these problems and we will see the solutions in next class.